The universe is full of wonders, each more mysterious and awe-inspiring than the last. As we gaze up at the night sky, we're reminded of just how vast and unexplored our cosmic neighborhood truly is. And one of the most intriguing discoveries lies right next door, Proxima B, a planet orbiting our nearest stellar neighbor, Proxima Centauri. This system is a mere stone's throw away in astronomical terms, making it a tantalizing target for scientists and dreamers alike. Proxima B is what astronomers call a super-Earth, a planet larger and more massive than our own, yet still rocky and potentially Earth-like. At just over 4 light-years away, it's the closest exoplanet we know of that could possibly harbor life. Its proximity to us makes it a prime candidate for future exploration and detailed study. In the grand scheme of the galaxy, it's practically in our backyard, fueling hopes that we might one day send probes or even people across the interstellar gulf. Proxima B's size suggests it could have a strong gravitational pull and perhaps a thick, protective atmosphere. Such an atmosphere would be crucial for shielding any potential life from harmful radiation and for maintaining stable temperatures on the surface. Orbiting its cool, dim red dwarf star every 11 days, Proxima B sits comfortably in the so-called Goldilocks zone, the region where conditions might be just right for liquid water to exist. Water, as we know, is essential for life as we understand it. The discovery of a potentially habitable planet so close to us is nothing short of a game-changer. It opens up new possibilities for finding life beyond Earth, and challenges our understanding of how common habitable worlds might be. Proxima B's existence suggests that Earth-like planets could be far more common in our galaxy than we once believed. With billions of stars in the Milky Way, the odds of finding other worlds like ours suddenly seem much higher. Its mass hints at a dynamic geology, perhaps active volcanoes, shifting tectonic plates, and cycles that could recycle nutrients, all of which are important for supporting complex life. Because Proxima B orbits so close to its star, its days are likely bathed in a perpetual reddish twilight. The sky would glow with a deep crimson hue, creating an alien yet strangely beautiful landscape. Imagine standing on its rocky surface, gazing up at a massive red sun that dominates the sky and never truly sets. The world would feel both familiar and utterly foreign, a place of endless sunsets and eternal twilight. Proxima B is more than just a distant dot in the sky. It's a world with its own unique story, its own mysteries, and its own potential for life. Every new discovery about this planet brings us closer to understanding our place in the cosmos. As a natural laboratory, Proxima B offers scientists a rare opportunity to study how planets form, evolve, and perhaps even develop the conditions necessary for life. It's a living experiment, unfolding just beyond our reach. With Proxima B so close, we have front-row seats to a new cosmic drama, one that could redefine what it means to be alone, or not alone, in the universe. When the James Webb Space Telescope turned its powerful gaze toward Proxima B, the closest known exoplanet orbiting another star, anticipation ran high among astronomers and dreamers alike. We expected to see the usual indicators of habitability, perhaps an atmosphere, water vapor, or the subtle chemical fingerprints of life as we know it. Instead, what we found was nothing short of astonishing, a pattern of lights shining on the planet's night side, visible from light years away. These weren't random bursts or fleeting glows, but organized, persistent points of light. Grids and clusters that seemed to trace the outlines of coastlines and the shapes of continents. Natural explanations, auroras, volcanic eruptions, wildfires, were quickly ruled out by the data. None could account for the regularity or the sheer scale of these illuminations. The lights were steady, clean, and structured, unlike anything nature produces on such a vast and organized scale. Their clarity and persistence defied all known natural phenomena. The patterns suggested networks, some linear, some clustered, remarkably reminiscent of the way cities and roads appear from orbit on our own planet at night. Even more intriguing, the lights pulsed in rhythmic cycles, as if following a planetary schedule or a coordinated system, hinting at a kind of global rhythm or communication. This level of organization points unmistakably to intention, not mere chance, a sign of intelligence shaping the darkness. It's as if we're witnessing a living map, a world illuminated by the presence of its own civilization, broadcasting its existence into the cosmos. The implications are staggering. For the first time in human history, we may have found evidence that we are not alone in the universe, that another technological society exists beyond Earth. These lights could be more than just illumination. They might be a beacon, a deliberate message sent across the void. We are here. We exist. The discovery has ignited debate, wonder, and excitement worldwide, sparking new questions and dreams about our place in the universe. What does it mean to be human if we have neighbors in the cosmos? How will this knowledge change us, our hopes, and our understanding of life itself? None of this would be possible without the James Webb Space Telescope, or JWST. Its massive gold-coated mirror collects faint infrared light, revealing distant worlds in unprecedented detail. JWST's coronagraph blocks starlight, letting us directly image planets like Proxima B. During long exposures, the mysterious lights on Proxima B's night side came into view. Spectroscopy revealed water vapor, carbon dioxide, and methane, potential biosignatures. But the light's spectrum matched artificial illumination, not natural processes. JWST is now our primary tool for monitoring these lights, searching for patterns and industrial signatures. It is our silent observer, waiting for Proxima B to reveal its secrets. Proxima B is tidally locked, one side in endless day, the other in perpetual night. The day side is likely a scorched desert, the night side a frozen wasteland. Life could survive in the twilight terminator zone where temperatures are moderate and water could exist. Here, the red sun hangs on the horizon, casting a permanent sunset glow. Winds might circulate heat and moisture, creating dynamic weather and habitable niches. A thick atmosphere could help distribute warmth, making more of the planet livable. But the lights on the night side suggest something more. Perhaps a civilization that has mastered its harsh environment. They may have built climate-controlled habitats or underground cities, expanding into the frozen dark. The lights could be the visible sign of this advanced engineering. Life on Proxima B would need to be incredibly resilient. Plants might be black or dark red, evolved to capture the dim, red light of their star. Animals could have heightened senses, adapted to a world without day or night. The constant twilight would shape unique ecosystems. Surviving on the night side would require advanced technology, vast, heated habitats, perhaps underground or beneath ice. The lights we see could be the glow of these cities. There's another possibility. The inhabitants may be synthetic, not organic. Machines could thrive in the cold, drawing energy from geothermal vents. The lights might be the nodes of a planet-spanning artificial intelligence. The possibilities are as mysterious as the planet itself. The mysterious lights observed on Proxima B have sparked intense debate among astronomers and astrobiologists alike. What could possibly be causing these unusual, persistent glows on a distant exoplanet orbiting our nearest stellar neighbor? As the saying goes, extraordinary claims demand extraordinary evidence. Before we jump to conclusions, every possibility must be carefully examined and tested. Some researchers suggest that rare volcanic activity could be responsible. Imagine minerals on the planet's surface glowing brightly under intense radiation, creating patterns that mimic artificial lights. Others propose a more biological explanation. Vast colonies of bioluminescent organisms, similar to the glowing algae found in Earth's oceans, but covering entire continents and shining with an intensity visible across interstellar distances. However, natural processes almost never produce stable geometric grids. Patterns in nature tend to be irregular and organic, not perfectly ordered. The lights on Proxima B, by contrast, display a remarkable structure and consistency. Their grid-like arrangement and long-term stability hint at something more deliberate, perhaps even artificial. Natural phenomena, like lightning or auroras, are chaotic and fleeting, yet these lights remain organized and enduring, persisting night after night. The patterns are eerily reminiscent of infrastructure, power grids, city networks, or even highways, suggesting the tantalizing possibility of intelligent life at work. To truly solve this cosmic mystery, we need more data, precise spectral analysis, long-term monitoring, and targeted searches for industrial heat signatures or chemical traces that could indicate technology. Each new clue, no matter how small, brings us one step closer to uncovering the truth behind these enigmatic lights. Are we witnessing the unmistakable glow of alien cities? Or have we discovered a new, spectacular natural wonder that challenges our understanding of planetary science? Whatever the answer, it will reshape our understanding of life in the universe and perhaps our place within it. The investigation continues and the cosmos holds its breath. To imagine life on Proxima B, we look to Earth's extremophiles, organisms thriving in boiling vents and Antarctic ice. Some live in total darkness, feeding on chemicals, not sunlight. If Proxima B has subsurface oceans warmed by geothermal heat, life could exist in the dark just as it does here. The lights might be energy facilities for a hidden biosphere below the ice. Life on Earth shows incredible adaptability, surviving in rocks, in cold, and in darkness. Proxima B's harshness might actually create unique, stable habitats. Studying Earth's extremes broadens our view of what's possible elsewhere. The discovery of lights on Proxima B could redefine humanity's place in the cosmos. For millennia, we've wondered if we're alone. If these lights are artificial, life may be common in the galaxy. We'd become part of a vast cosmic community, not the center of the universe. The search for answers is urgent. New telescopes, radio searches, and even robotic probes are being planned. Whether the lights are alien cities or a new natural phenomenon, the outcome will transform us. We stand at a crossroads in history. Soon, we may answer the oldest question, are we alone? Whatever we find, we'll learn something profound about the universe and ourselves. The stars are waiting.